Okay, we're going to get started in 1 minute. All right. Hi, everyone. My name is Nick. I'm a product manager on Exchange, and welcome to this session as part of Technical Airlift. So we're going to be talking about Exchange Online support for continuous access evaluation, or CAE. And we're going to take a look at tracing how CAE works. So you'll get an understanding of what to look for in network traces and specifically how the three parties involved in CAE talk to each other so you can understand how the feature is working. All right. So yeah, we're going to start and explain how Exchange enforces continuous access evaluation so that you'll be able to do this yourself and validate or diagnose or analyze CAE working for Exchange and your tenant. And at the end, we'll have some time for questions and open it chatting. I think the presentation should take about half an hour, so we'll have a good amount of time for questions at the end. I won't be able to see the chat. So if you need to interrupt because something is unclear, you can unmute yourself. I think we've got a small enough group for that. So just speak up. And I can't see the chat, so just unmute yourself and chat if you need to ask any clarifying questions as we go. That's fine. All right, so let's get started with talking about what is continuous access evaluation. So continuous access evaluation is a change in the way we do policy and access control enforcement. Typically, I'm using the illustration on the right here to show that as a token gets issued, the policies are enforced, and then as time goes on after that, the policies aren't enforced. So I'm showing it getting darker blue there. That's to show that we periodically check these policies. The main change with continuous access evaluation is that the tokens might happen to live longer, but we're continuously checking all of these access control policies and indicators that we need to. So it improves the security posture of sessions accessing Exchange in this case. And the way that CAE is accomplished is a tight collaboration between three parties. So we've got a resource provider like Exchange in this case, a client which knows how to perform CAE related things, and an identity provider which issues tokens. In this case, it's Azure Active Directory. So all three of these pieces need to be working for CAE to function properly. Specifically in Exchange, there's two sorts of functions that CAE performs. The first is policy enforcement. So this is name, location, and IP address policies. This makes sure that a request from a client is coming from a particular IP address. That's the policy enforcements that Exchange supports today. Separately, there is revocation event-based CAE. So these are events that are generated by the token issuer, like when a user might change their password or if their risk goes higher for some reason. These are event-based CAE revocations. So you can either have a request out of compliance of a policy, or you can have something happen which triggers all sessions from before that time being revoked. So the second that event happens, any token issued before that event would need to be revoked, and that's the event-based revocation. So let me walk you through how CAE actually works under the hood. So first of all, policies are synced from the identity provider to the resource provider, Exchange in this case, and these are those IP address policies. Separately, revocation events are synced over from the identity provider over to the resource provider. I missed the SLA actually. So policies, there's a 2-hour SLA for them being updated if you make any changes. And there's a 15-minute SLA for the events because we want the events to be pretty quick. That's the SLA. Actual enforcement time is a bit quicker than that typically for the event-based revocation. So after Exchange has these pieces of information, the policies and the events, on every request from a CA-capable client, we evaluate the appropriate policies and ensure that that user has not had any recent revocation events that require them to go get a new token from the identity provider. Okay, and if you fail either of those checks, we return what's called a claims challenge. And you're actually going to see a claims challenge later when we do the demo portion of this talk. And that claims challenge basically says that the client needs to go and get a new token from the identity provider because either one of the events or the policies rejected the access request to the API. So the client has to be CA capable. When they're CA capable, they know what a claims challenge is, and they know how to provide that back to the identity provider to obtain a new token. Just another note, there's in the access token, and I'll be showing you this, there might be policies that apply to only some users. So the way that Exchange knows which policies to apply to which requests is that in each access token, there's a list of policies that the identity provider needs us to enforce. And they will decide which policies that token needs enforcement for. So a tenant might have 10 policies, but only one of them might apply to one user. So it's important to understand which policies apply, and we'll show you kind of how to trace that. Okay, so now we're going to hop into showing you how to validate, diagnose, or analyze this feature functioning in a tenant. I've got some pre-recorded videos, which I'm going to do narration over. And we're going to show you one of each variety. So the first one we're going to show is an event-based revocation. In this case, I'll click sign out of all sessions, but you saw the table earlier. There's a bunch of sorts of events that can happen. And then we'll go and look at an example when my IP address changes and what that looks like. Okay, so the tool I'm going to be using here is Fiddler Classic. And we're going to be using this on the client side. That's you see on the diagram. I've put network traces over there just to show that we're capturing. So this is something that any client can do on a computer. You don't have to have special logs from either side of the identity provider or resource provider. This is a way to kind of observe CA working from your side. We're going to take a look for the 400 series errors, which indicate access denied from a revocation. And sometimes there's a few of those. So the trick is to look for the 400 series error with a big body because that contains the claims challenge. Sometimes the subsequent request afterwards, the resource provider doesn't repeat the claims challenge. It just assumes the first one was communicated. So that's the only nuance to finding the correct row in the network traces. Okay, so now I'm going to hop in here. So first I'm starting up Fiddler, and we're going to take a look at a network trace. I'm using Outlook Desktop for this example. And what we're going to do is we're going to trigger some action that calls the Exchange APIs. And we're going to go and take a look at one of those requests to see the access token that's being used. So I'm going to look at anything with outlook.office.com here, and I'm going to go look for the authorization header. And I'm going to go take a look for the access token. And it's important that we do this to understand that the access token is subject to CA enforcement because not every access token is. And the tokens that need CA enforcement have a special claim, which you'll see shortly, that indicates that the access token is subject to CA. It's up to the identity provider to determine which access tokens need CA enforcement. So if you use a client which isn't capable or updated, it might not need CA enforcement. Here I'm just getting the access token. I'm using a token decoder here. And I'm just looking at the access token inside of a proof of possession token. So I'm copying and pasting that access token twice, but you might not see that in your tenant if you're not using proof of possession. So this is the key claim, XMS SSM1. That means that this access token requires CA enforcement. If it's not equal to 1 or the claim isn't present, then CA enforcement is not needed for that request. The thing that predates the XMS SSM1 is the XMS CC claim, also at the bottom there. That indicates that the client was CA capable, and you can only get XMS SSM equals to 1 as a claim if the client can handle CA. So you will only ever see the two of those together, or you'll see XMS CC by itself, but not a CA token if the identity provider chooses to not have CA enforcement on that request. So now we're going to go and trigger a revocation event. We've confirmed that we have a CA token being used in this client, and that means that any revocation event will need to be enforced right away. So I'm just checking that my access is good still, getting 200s. And in this case, I'm going to switch into Microsoft Admin Center and go and explicitly click to revoke the user who is signed into Outlook Desktop here. I could also change their password, or if their risk went up, this would happen. Remember the table at the beginning, there's a lot of reasons, but in this case, I'm explicitly clicking to revoke all the sessions for that user. And now I'm switching back to Outlook Desktop. And I wanted to give an honest experience here. So we're going to be refreshing this until the revocation happens. Remember the revocation event comes from AAD over to Exchange. There's a bit of a sync process there. And we have that SLA that it happens relatively quickly within 15 minutes. In this case, I know the example, but it tends to be faster than that. So I'm just giving you the true testing experience here where you would reload to wait and find out when the revocation takes effect. So just bear with it for a second. Okay, so now we've got an error on syncing. I'm going to go take a look at the network traces and see and confirm that this failure to get the data is based on CAE. I'm pausing the capturing, and I'm taking a look for the 401 errors here. And when I'm looking at the 401 errors, I'm looking in the error for the claims challenge. You can even search claims challenge, and it will highlight the ones that has that. So we can see here, there's a 401. Coming from outlook.office.com, and we look at XMS diagnostics. This gives a little bit of information as to why the access request was denied. That's just for your information for debugging. The actual header that the client uses is the www authenticate header. And I'll pop that out here for you to take a look. Specifically, you need the error insufficient claims, and then the claims are listed after that. And these are base64 encoded. So we're copying these claims, and we're just going to quickly use the token decoder to unencode these. Just a little bit of a trick. So that's the actual content of the claims challenge, indicating that the access request was denied at this time based on the events that had synced over to Exchange. And after this claims challenge is received, the client needs to go and get a new access token. It might do that in the background, or it might need the user to authenticate again, or they might not be able to access anymore because their risk remains high. So the key is that the client goes back to AAD and tries to get an access token, and then AAD can decide what to do from there. Okay, so now you've seen an event-based revocation. You saw in the token that we checked that the token was CAE enforcement required, XMS equals 1. And then we looked in the network traces for requests to Exchange after a revocation event, and we saw the 401 happened relatively quickly. Needs to happen within 15 minutes. That's the SLA. Let's take a look at the other flavor, which is policy-based enforcement, and specifically an IP policy. So here's an IP address conditional access policy that you configure in Azure Active Directory. This particular policy requires that the user come from only one IP address. So I'm going to start from that IP address and then take my computer off that IP address so you can see the revocation happen right away. This one doesn't require an event, so you don't have to wait. It's instantly because the request comes from the wrong IP, so it's enforced right away. So we're going to start by checking that the session is subject to CAE, and we're this time also going to look to see which policies are applicable to this token, because AD might choose to have certain policies apply because they don't apply to certain users or things like that. So I just refetched data, and I'm going to go take a look at one of the 200s here to get an access token. So I'm grabbing the access token from the authorization header on one of the requests that succeeded to outlook.office.com. I'm just showing the raw and different views here in Fiddler. And we're going to decode this access token now. This one also happens to be an proof of possession token. You might just see the access token, but sometimes it's an access token inside an access token. So here, you have to go until you see this. And And there's one more thing to look for here. So we've confirmed that this is a CAE token, XMS SSM equals 1. This token needs CAE enforcement. We can see that the client that requested the token was CAE capable, which it had to be to get XMS SSM equals 1. Ignore this IP address thing. Just one sec. And the key we need to look for here is, are there any policies that this token is subject to? So that is listed in a claim called Capolids late bind. There you go. So we can see that there is a single policy ID that needs to be enforced. And that if that Capolids late bind claim is not there, then the token isn't subject to any IP enforcement. You might have 1, 0, or many policies there. And it's the token issuer which decides which policies need to apply to each session. Exchange will just enforce what is in the token. So now let's go and see this in action. We're turning Fiddler back on, and we're going to go and take a look at the client making a request from an allowed IP address and then moving to a non-allowed IP address. So here we're triggering another request to the server, and the data comes back. In Fiddler, we can see the 200s from outlook.office365.com. And you'll just have to wait a second here while I go and this is pre-recorded, so it's not going to interrupt the live stream, but I'm switching my computer over to an IP address that is a mobile hotspot. This could also just represent you taking your computer and walking over to Starbucks or leaving the allowed IP address range for the company. Just one sec while that switches over. Okay, now we're going to hop back to Outlook and we're going to try to get more data again. And we should see the rejected access because we're now coming from an unallowed IP address. So there we saw the rejection. We're pausing Fiddler again, and we're going to take a look at the 401 error. Remember, there's a few 401s sometimes, so we're looking for the one that has the body. The body column is in the table on the left. You can see there's one there with 400. That one has the full claims challenge in it. So here we can see the error is a little different this time. It says that the check failed based on the IP address this time, as opposed to the revocation event. So that's just a little friendly thing in the body and in XMS diagnostics. But separately, we have to look at the www authenticate header because that's what contains the actual claims challenge used to communicate with the client. So yeah, that's the IP address check failing. Just some tips. And I'm just going to copy that we see insufficient claims that confirms the CAE rejection. And now we can go to see the specific reason inside the claims challenge. And this claims challenge is then passed from the client back to Azure Active Directory with a request for a new token. So we're just going to use this trick to decode the base64 encoded thing here. We'll see the claims challenge here, which includes the timestamp. Importantly, for IP addresses, you'll see one additional thing when we're enforcing a policy. You'll see XMS RP IP adder inside the claims challenge. That indicates the IP address that Exchange saw on the request. So if you think about it, a client might talk with Azure on one IP address and Exchange on another IP address. And Exchange only looks within its window. It says, okay, here's the IP address that we're rejecting, and it checks the policy. So this claim is used to communicate what IP address Exchange saw back to AAD because there's a chance that they might be different. And there's some, well, I'll explain a little bit more about that, but this is the key to understand kind of what IP Exchange is seeing your client come from if you're trying to trace, hey, why did this request get rejected? That's the IP we're seeing, and that's why it got rejected. Okay, the next few slides are kind of me rehashing about what we talked about, and it's also meant as a bit of a reference guide if you want to look at the recording afterwards. So when you're finding access tokens, you need to obtain a request to the resource provider, Exchange. So for us, we can look for the Office 365 target URL. For Outlook Web, there's a little bit of a finicky thing where the access token is harder to find. It is contained in the first 302 post request after a login. After that, it's passed back and forth using a cookie, so it's harder to find than Outlook Desktop, but using that tip, you should be able to find the token still. When you're looking at access tokens, you can look at the issued at time, IAT, and EXP. That'll indicate to you the token lifetime. CAE allows tokens that are longer lived, so you might see 28-hour tokens or longer. XMS SSM 1 is the key claim that says this token needs CAE enforcement from the resource provider. That could be Exchange or SharePoint or anyone else. So that's the claim you look for to make sure that this session is subject to CAE, because not all of them are. Capillid's late bind is the claim that indicates, sorry, just checking the time. Capillid's late bind is the claim that indicates the list of policies which need to be enforced for that session. Not every policy in the tenant gets enforced to every user, so you need to go and make sure that the specific policies are contained here that you're troubleshooting. XMS CC is just indicating the client was claims challenge capable. Some common confusions we've seen when analyzing CAE is expecting an IP address enforcement when there's no Capillid's late bind claim present. So there's several reasons why that could happen. We can get into that a bit afterwards, but for troubleshooting Exchange, this is what you would need to take a look for. Or expecting CAE enforcement when that XMS SSM1 claim is not there. And there's reasons why that might not be there as well, which we can get into. The testing IP address policies, I can give a bit of an overview. That's also meant a little bit as a note for afterwards. When you're looking at the responses in Fiddler, you need to look at the www authenticate header. That's the header that is used to communicate from the resource provider back to the client, and that's what contains claims challenges. There might be multiple 400 errors, so you need to look for the one that contains the claims challenge. Sometimes it's not repeated, and that claims challenge is also base64 encoded. So if you want to take a look at what's inside, you'll have to decode it. You can use that trick with jwt.ms to decode the tokens, or you can use any other base64 decoder. Okay, now let me give a little bit of an explanation as to why there's some nuance with IP testing, and we can explain a bit why some tokens might not be CAE and some tokens might not have some policies needing enforcement. So there's a few examples, but the two key ones are based on the idea that the resource provider, Exchange, and the token issuer, AAD, might see different IP addresses for the client making a request. This could be, some of the known reasons are the Exchange supports IPv6 and AAD does not support IPv6. So if you go and talk to AAD with a client, you'll switch to v4 address. And when you go and talk to Exchange, you'll be seeing on a v6 address. So unless your policy talks about the allowable v4 and v6 addresses, Exchange seeing a v6 address might reject you and say, oh, okay, well, we're seeing this address that's not allowed, while AAD sees the v4 address that is in the policy and is allowed. So when there's that mismatch, the way AAD breaks that tie is that if we see something that's not allowed, an IP address, and we reject, and we pass that IP address back to AAD, and they see an IP address that is allowed, they reduce the duration of the token to be only 1 hour, and they ask the workload to not enforce that policy anymore because they're just going to enforce it every hour on token issuance. But they leave the XMS SSM1 claim there so that we can still enforce the revocation events. So that's one example why a policy might not apply to a request anymore. It can be due to network configuration reasons. Another one is if you explicitly have network configuration reasons where the two different IPs seen in AAD and Exchange differ. Some people have split tunneling configured on their VPN, for example. So it's very important to go and take a look at the revocations and see what IP address Exchange is seeing. You can compare that to the sign-in logs on AAD's side. And ideally, you would have the IP address seen by Exchange and AAD listed in the IP address policy. Okay, and if you need to communicate with support because you found some issue, what we walk through here today is important to supply. Essentially, just communicate whether you're seeing that there isn't a policy enforcement or there isn't an incident enforcement. Talk in terms of UTC about when certain things happened, when revocations happened, so logs can be traced. Talk about the clients that you're using because CAE support differs there. And then ideally, you'd supply the Fiddler trace that I just showed everyone how to collect using Fiddler Classic and the bearer token that the request was subject to. You can also put the row numbers in Fiddler. If you can't do that, it's important to have the tenant ID, specific users. You can get some of those details from inside the access token. And also go take a look for the claims challenge and send that over. Okay, at this point, I'm just going to open up to questions. I didn't get interrupted anywhere, so I hope everyone followed and we didn't lose anyone there. But if there's anything confusing from the presentation, feel free to bring that up now. And also, I've got these kind of thought-provoking questions as well. Okay, let me see the chat. So feel free to unmute yourself, by the way. I think you should be able to do that if there's any questions.
Hey, this is Charles here. Is it possible to put some of the link there so that we can, double check later? That's what I have.
Yeah, so if you're looking for the presentation, this meeting will be recorded, so you can take a look at that afterwards, if that helps. We can look about sending out the presentation file also to everyone who attended. I'll look into that afterwards.
Okay, and if you have like I know you were showing some link about how it breaks down all the this and the what do you call it, the token. If you have maybe URL link that you can put in the chat so that we can take a look of it.
Oh, the website to decode the tokens?
Yes.
Oh, sorry. Yeah, I got you. So I'll put that in the chat. You can use that.
Thank you.
Any like JSON web token decoder can be used as well, but that's the one that I use. Okay, I'm just seeing the chat now. So I guess people are chatting about Fiddler. So that was Fiddler Classic that we were using there. Is there a version of Outlook, list of versions of Outlook that are CA capable? I think in the CA documentation, it does list that, but we can follow up with that. I don't have the answer, sorry. I think essentially anything released in the last 2 years, Megan. That's a good point though, because if the client doesn't emit the XMS CC claim, then it won't be asserting that it can handle C, and it won't be getting C sessions, even if the token issuer and resource provider are both able to handle C. All three need to be ready to initiate C. So the client needs to be ready. Okay, yeah, I see you have a lot of people using 2016 Outlook. Yeah, doing an upgrade there will add some value because the security will be better. So that can be a way to advocate for the update. Another thing I didn't mention is because the continuous enforcement of policies, longer-lived tokens can be issued. So C is separate from the longer-lived tokens, but one benefit of C is it enables the use of longer-lived tokens, which can help your tenant be more resilient to any outages from the token issuer. So other than the security posture improvement, it's also helpful for resiliency to use CAE. That's another reason to make sure the clients are all updated. Okay, I'll just seeing no more questions in the chat. I'll just read out a few of the things I was interested in. So I'm wondering when these tracing processes that I showed off would be useful to you and your tenant. Is this mostly support cases, or are you doing validation of the feature to do acceptance testing? My second question is around troubleshooting. I know people do use the Azure AD Sun in logs today, but they don't contain everything with regards to CE. So that's partially why you need to do client-side tracing today. I'm just wondering if people are using these Azure AD Sun-in logs to troubleshoot CAE. Also wondering what brought you all to the session, what was interesting about CAE so far, what the experience has been so far with it in GA, and then any other thoughts, feedback, generic feedback on anything related to CAE for Microsoft that you want to share. So feel free to unmute or type in the chat. Okay, must have been super clear then. If also if anything was confusing in the demo, let me know. I can go back and explain things. Okay, well, last call for questions. I'll stay around another minute or two, but if folks don't have any, then we can end early. Okay, there we go. I see some. So I knew about tokens, but I didn't think I had thought about CA before today. We do a lot of troubleshooting with Fiddler, but hadn't had issues with this. Okay. So now, Megan, you know about the special claim in the tokens that kind of indicates CA is going to be enforced. You could use that knowledge to go and take a look at Exchange or other workloads as well, because CA is available in like Teams and SharePoint as well. Can we do a demo for how to capture an access token from OA real quick? I don't have all my test tenants set up for that right now, so we might have to follow up with like a blog post or something on that. In terms of the OA testing, though, I'll just go back to my tip here. So I'll explain it again just in a bit more detail. So basically, because Outlook Web doesn't pass the access token with every request, they instead use a cookie. You need to go and be a bit careful to find the access token that Outlook Web is using. And the way you can find that is starting a network trace right before you log in. And if you look for the first 302 post request after login, that will contain the authorization header with the access token. After that, you won't see it with requests. So to go and find the specific token that's needed there, the specific token that's applying to the subsequent request from OA, you have to first get this token at the beginning after login. You can't just hop in on any request like you can in Outlook Desktop. Okay, I see We use conditional access with a lot of policies already, so it's good to know a bit more when there are clients unable to connect. Yeah, I think it's important to take a look at that capitalids late bind claim, Megan, because that explains which policies are going to be enforced for that request. And that can help you pinpoint what is causing the rejection. Even if you look at the requests also at the XMS diagnostics header or in the body, you'll see, hey, it's an IP policy. And at least that way you can know that it's the IP policy that's causing the unable to connect versus something else, because there's other issues that can come up, right? One funky thing about the policies I've talked over, but it's a bit confusing, so I'll just reiterate it again, is if you come from if you have a policy in an access token, so let's say you start off, you get a C access token from AD, and it contains some policy. If Exchange rejects you and says you're not coming from an IP that's allowed by that policy, that'll be passed back to AD. AD might issue a token without that capitalids late bind claim, or without that policy in the capitalids late bind claim, because they saw an allowable IP from their side. So we see a lot people getting confused by like complex networking setups. But essentially the idea is that we'll give you these long-lived CE tokens, but if there's any problem, we'll revert to the old behavior of enforcing these every hour. Ideally, that wouldn't happen because we want it to be continually enforced. But if you happen to talk to Exchange from an unallowed IP address and AD from an allowed IP address, then there needs to be some sort of tie breaking, and that's AD's the winner of the tie there. Other than split tunneling, people end up in that situation because of v6 addresses, and the fix to that is to go and make sure your v6 addresses are in your CA policy on the Azure side, because then Exchange will see you coming from the v6 address and allow you, and Azure will see you coming from another v4 address and allow you, and then there's no problem. And that's how you can make sure the IP policy enforcement doesn't get removed from the session. Okay, so there's a question about what would happen if a non-CA capable client tries to connect to a resource like Exchange. So right now, when the client requests an access token from Azure, it asserts whether it can handle CA, and that results in either a token without XMS SSM equals 1 or a token with XMS SSM equals 1. At the moment, Azure is happy either way, and they'll issue tokens either way. You could imagine in the future, though, that we want to have all of our clients using this, and we might stop issuing tokens outside of CA, but we're a long way away from that today. So right now, there's no problem. CA is an optional additional security and resiliency policy. It's an optional additional feature to use to improve your security and resiliency posture. So if you don't have a client capable of doing that, you just won't get CA, and you'll miss out on those benefits. What specifics could we look on the Azure AD send logs to gather data in the network? That's a good question. I haven't used the Azure AD logs too much. I know they don't include a ton of details. So that was actually one of the things I was curious about, if you want more of these CA things in those Azure logs. I suspect that it's a bit of a pain to go and do client-side network tracing like I demonstrated here. But currently that's the only way to understand like what IP address Exchange show you coming from, or the fact that Exchange rejected you. Those don't show up in the Azure sign-in logs. I think they just show new tokens or something like that. So if you want more in the Azure logs, give a thumbs up in the chat, and we can take that as feedback. But if you don't give a thumbs up, I'm going to assume you're quite happy doing the fiddler traces, and we won't go and add anything there. So you can see why conditional access policies fail in the logs. So to bring it back to our diagram here, things that end up in the Azure AD Sunon logs are coming from the identity provider side. So you'll see what happens when the client goes back to Azure AD and asks for a token and fails a policy. That'll end up in the logs. But if a client has a token and comes to Exchange and we reject them because of that policy, that doesn't get explained in the logs. But what would happen is we would reject them, and the client would go back to Azure, ask for no token, ask for a new token, and then the same policy would trip. So technically, the policy is getting evaluated twice there, and what you're seeing in the logs would just be from the Azure side. Separately, it's being enforced on Exchange though. And the only way to see that that has happened is to look in the Fiddler traces where you'll see the policy having failed. We separately have like internal logs that we keep for some things there for troubleshooting, but there's nothing exposed to you all to see on the Exchange side.
I think that's the biggest challenge, Megan, with troubleshooting Exchange Online all the time, is that you have some resources on Azure, but Exchange is its own thing and Azure is its own thing. And sometimes we have problems between the sync on-prem and Azure, and then sometimes we have problems between Azure and Exchange sync. And then sometimes you have problems with the authentication. And so trying to pinpoint where the exact problem is can be really difficult. And then, of course, I work for a health organization, so trying to get doctors or anyone else to actually, to use their machine is almost impossible. And I would imagine that's probably true for a lot of other industries too. So yeah, I mean, if we had more information about how the client is communicating with Exchange, it would be really helpful, because a lot of the errors that we see now when we're trying to troubleshoot why someone can't open their mailbox are just obscure, like unknown error that you'll see. And we're pretty good now at solving a lot of them. A lot of them are dumb things like archive GUIDs and stuff, but you don't know where that error is if you're just looking at it in the beginning, if you have no experience. And in the meantime, the client can't open their mailbox.
Okay, so I'm hearing, I mean, for the CE context, if CE revocations were kind of listed somewhere, for example, that would help you avoid doing client-side traces, which is hard for you because you can't necessarily get the user to go repeat the behavior because they're a doctor and they're busy.
Yeah.
Okay, so it'd be better to have kind of retrospective logs where you could see, all right, Exchange did a rejection for this reason.
Oh yeah, that would be amazing, just to have more visibility in how the client is communicating with Exchange Online.
Thanks for sharing. Has anyone run into any confusion with like split tunneling or IPv6? I know that was a issue people were troubleshooting and trying to wrap their head around a lot a few months ago, but I haven't seen as many support cases on that front recently. The challenge for us in helping like diagnose, so often what would happen is we would get a support case where the root cause ended up being some networking configuration. But because that is personally identifiable information, like we don't log all that stuff on our side. So that's where Fiddler was needed to go and understand, hey, what IP was exchanged, things like that. So that's partially why we're saying this Fiddler is like key to like troubleshooting, because even us on the Microsoft side don't log everything we need to reconstruct exactly what happened. Has anyone been interested in service principal C support for Exchange? I know this is something that other workloads are implementing, but I haven't heard any urgent need for it from Exchange folks. So this would be, instead of a user having a revocation event, it would be a service principal, and you could also do the IP enforcement for them. All right, I will move us on here to the thank you slide. Thanks so much for joining the call. Feel free to reach out over email if you want to ask any other questions or chat more about this. But thanks for your time, and hopefully hello to anyone watching in the recording in the future.